So we've got 5, 7, which is complex numbers and roots. So these are complex numbers and roots, things that we don't normally deal with. We used to have a problem that when we were dealing with quadratics or things that were like x squared, we would run into a problem. And the problem was this. We would get here, like this is the graph of x squared plus 1. That's what it looks like. It doesn't really look like a problem, except for what happens when we try to solve it. When we try to solve it, we subtract 1 from both sides and we get here. And then we would take the square root of both sides and we would get x is equal to plus or minus the square root of negative 1. But where does the problem lie at that point? Like up till now we couldn't do that because of y. Like why can't I go forward?
Because you need a positive and a negative number.
Well, not just a positive and negative number. I need like some number that multiplies times itself to give me negative 1. Well, let's see. 1 times 1 is 1. And negative 1 times negative 1 is 1. Neither one of them meet that condition. And this is what the graph shows right there, is normally when we get x equals something, so we would go like this, no real solutions. And we weren't wrong when we said that. It's true, there are no real solutions. However, what we're asking for is when we're asking for x in terms of real solutions is where does this cross the x-axis? Every time it crosses the x-axis, we get a solution. But does this graph cross the x-axis? Does it cross that red line?
No.
It never crosses that red line. So we came up with no real solutions. But now we get into something called imaginary numbers. These are not numbers that you can find on a number line. They do not have a value like they would, like you can't calculate what it equals to. It's not equal to like 3.5. What we're going to do is we're going to start off with this understanding right here. This is the fundamentals. If you miss this part, you will miss everything going forward. From now on, whenever we see the square root of negative 1, we are going to say it equals I. And what we mean is it equals an imaginary number. That can't be a real number. It's what we call an imaginary number, is because we are going to have ways of dealing with this, we need to start with that the normal numbers that we use will not make this happen. The normal numbers of, all the positive numbers and all the negative numbers will not make that happen. So this is the first time we get into a number system. I mean, when you think about it, since you were in kindergarten, where we're like, it's not real numbers, these are imaginary numbers. So here's the idea. Whenever I have the square root of negative 1, okay? Whenever I have the square root of negative 1, I'm going to say that that is equal to I. Remember this, because we're going to go forward using this idea, and this alone is going to help me solve it. All it means is that the square root of negative 1 is an imaginary number. That's it. It's not a real number, it's an imaginary number. So, what we're going to do is, for these, I couldn't normally do this, because 8 times 8 is not 64, and negative 8 times negative 8 is not 64. So whenever you see a negative under a square root, now this is a square root because remember what hidden number is right there. It's a 2. It's a square root. So here's what I'm going to do, and this is going to help me solve this every single time. Would you agree that these two things are exactly the same? What I have above and right there are exactly the same. Okay, now I'm going to break this up. The square root of negative 1 times the square root of 64. This just became something I can do now. Because a moment ago, we learned how to deal with this. What did we say this is going to equal? I. So I'm just going to write I. This part right here is equal to I. But I have not dealt with the 64. This is something I have known how to do for a long time. What is the square root of 64? It's 8. So I get I times 8, and I use that I just like a variable, and I write it as 8i. The square root of negative 64 is 8i. 8 times an imaginary number. This imaginary number, which is the square root of negative 1. Final answer. So, the key strategy you're going to see every single time in here is that I am going to split these up. to pull out that -1, because the negative is the problem. So if I deal with that negative all on its own, it's going to become I every single time. The square root of -1 every single time is going to become I. And the other part I can deal with like we have in the past. So let's try this one. This is 3 times the square root of -16. 3 times the square root of -16. But this is a problem. The answer to this is not -4, and it's not 4. That part we can't do as of our old lessons because that is not a real number. So what am I going to do with that -16? Good. The square root of -1 times the square root of 16. Because if you think about it, if I were to multiply these two things back together, where I would get is there. These are the same thing. So I get 3 times, what is the square root of -1? I. And the square root of 16 is 4. What would I say 3 times I times 4 is? 12i. So it's actually really not that bad to deal with the square root of negative numbers as long as we are okay with the idea that this is an imaginary number. If there's time, I'm going to kind of squeeze in a little video at the end that kind of explains imaginary numbers a little better. It does a way better job with diagrams and 3D visual effects than I ever could. So if we have time, we'll sneak that in, explaining like why do we have imaginary numbers? How do they work for us? All right. So I have a negative on the outside. Okay, no problem. And then I've got this square root of -75. The negative on the outside isn't the problem. It's the negative on the inside that's the problem. So let's deal with it. How are we going to deal with it?
Split it up between square root of -1 and square root of 75.
Okay, so let's break this down into the square root of -1 times the square root of 75. 75. Now there's still this -1, which is like, it's a negative out there. It's a negative times that, but if you prefer, and I know a lot of people will, think of that as -1 times that. That negative out there is times -1. Okay, so there's this -1 out front. What does this square root of -1 become? I. And do we know the square root of 75? Okay, so how'd you get there? Let's break it down into the square root of 25 times the square root of 3. What's the square root of 25? Okay, now we have to put this all together. So we get -1 times 5 is -5. Then I times the square root of 3. Think of I like a variable, like you would like x or anything like that. It's not, it just represents the imaginary number square root of -1. It's not something you plug into, but understand that it holds the same position. Like it would go right after our whole numbers right there. It's before the radicals. So we've got -5i times the square root of 3. Are we okay so far? This one shouldn't be too bad. All right, you guys take it from here. What am I going to do? Split it up into? Okay, how did it become 2 radical 3?
You split it up into 4 and 3.
Good. I just want to show this because these are the kind of things that if you don't show, you don't get credit for. Some of you are getting very good at radicals, but I need to see how you got there because some of you are still making minor arithmetic mistakes, and I just want to make sure. So how am I going to write this final answer here? 2i radical 3. This is 2 times the square root of -36. Abel, hook me up. This is what we just did over and over again. Talk to me about this part first. Not sure?
Not sure.
Somebody else, hook me up. Faith, you want to hook me up?
Yeah. So you do 2 times square root of negative 1 and multiply that by the square root of 36.
Good, so she broke this negative 36 up into two things.
And then you get 2 times I from the negative 1. And then the square root of 36 is 6. And then you get 12I.
Beautiful. That's it. So we're always going to deal with that negative underneath there. Always, always, always. When there's a negative underneath there, if there's nothing that we can multiply inside there, like there's no work to be done, that it's going to like end up disappearing, it's just a negative 36, I'm going to pull out a negative 1. I'm going to like factor it into two things here. And now I can deal with it. As long as I have the square root of negative 1, I know that that will always be I. And you have to get used to doing that, because where this is going, we're actually going to use that definition to even get into more crazy things from there, is that as long as we know that the square root of negative 1 is I, we're able to do a lot of things that we could never do before. Don't be intimidated by the fraction. There's a fraction there. It's negative 1/3 times the square root of negative 63.
You split that negative 63 up to a square root of negative 1 square root of negative 63.
Good.
And then I split up 63 to square root of 9 square root of 7.
Okay. Square root of 9 and the square root of 7. He chose those numbers because they multiply to make 63, and 9 is a large square number that's in there.
So what I did is and then also make the negative 1 imaginary. So
Okay.
it would be negative 1/3 times I times 3 square root of 7. That equals square root of 3.
Okay. So negative 1/3 times 3. If you're not sure how to do that, just write it out. Negative 1/3 times 3, in which case just becomes negative 1. So what? Oh, thank you. My mouth works better than my brain here. Let's see. Square root of 7. There we go. So we get negative 1 times I times the square root of 7. Well, negative 1 times I just becomes negative I square root of 7. You don't need that 1 out front, just like we wouldn't do negative 1x. We're not going to do negative 1I. We're going to have just negative I square root of 7. Okay, let's do some solving now. So one of the things that we're going to be able to do is deal with things that we didn't have to do before. Does yours have the square root on there?
Yeah.
This should really be, to be able to solve this, we need this. To make a change here. This is actually very problematic the way it's written, so we're going to just make one change. Just take away this. We're going to make it x squared is equal to negative 81, which is then we can use the pattern that we're trying to use here. So that's what we should see there. And that's the one we're going to solve. So I apologize that that radical was in there. We'll go directly from here. So x squared is equal to negative 81. Okay, let's talk about what we do. It's not any different than what we've always done, except for we're going to know how to deal with something at the end. Let's take the square root of both sides. Now, since I introduced the square root to both sides, what do I need? Good. X is equal to plus or minus the square root of negative 81. Now remember, this is the part that we learned to deal with today, was good. So we've got plus or minus we are going to split it up into the square root of -1 times the square root of 81. Notice my plus or minus is still there the whole time.
Since 81 is a perfect square, so we make that 9 and negative 1's I. Would be plus or minus I times 9.
Okay? So we get x is equal to plus or minus, we write that 9 first, it becomes plus or minus 9i. Remember that I is not a variable, but it's like a variable in the sense of that we attach it directly to that coefficient. It's 9 times I, just like I would have 9 times x. Except for in this case, we're not going to plug anything in. I represents the value. This is what we're using the entire time, that I represents the square root of -1. That's why you will never, ever see I used as a variable. It's used to represent an imaginary number. You're going to see I all the time now, from now on. It is not a variable like x or y or z or m. Those things would not be the same. Okay, let's try B. Again, all of this is going to work out in the same way that it always has, except for at the end, we're probably going to be taking the square root of a negative number. That's kind of the whole goal of all this. So what would I do first? Let's subtract 75. And we get 3x squared is equal to -75. Divide by 3. And we get x squared is equal to -25. Square root of both sides. And when I do, I get x is equal to plus or minus the square root of -25. Good. Square root of -1 times the square root of 25. Okay. I times 5, or x is equal to plus or minus 5i. Positive 5i and negative 5i are both answers. All right, talk to me. Subtract 48. Subtract 48, and we get x squared is equal to -48. Square root of both sides, and we get x is equal to plus or minus the square root of -48. Okay, so how'd you get there?
I broke the 48 down to 6 and 8.
Okay, so 6 and 8. But I don't know the square root of 6, and I don't know the square root of 8. 12 and 4 is possible. Let's see, this becomes I. So let's break this down into, let's try that, 12 and 4. Do I know the square root of one of those two? Okay. So x is equal to plus or minus I times the square root of 12, and the square root of 4 is 2. But there's still something there. I'm hesitating a little bit, because the 12 can become what?
4 and 3.
4 times 3. So we get x is equal to plus or minus I. The square root of 4 is 2. I can't do the square root of 3 times the square root of 2. Which means we get x is equal to plus or minus 2 times 2 is 4. I times the square root of 3. Now, here's how you might have broken down 48 differently. If you wanted it to go a little faster, if you had done 48 like this, so we would still start off the same way. This is how I might have gone different than this. I know that this is I. So this is just separately. This is like how I might have gone different. This is actually the square root of 16 times the square root of 3. And you'll see it breaks down much more easily there. The square root of 16 is 4. And you could see then we would still end up with the 4i times the square root of 3. The plus or minus, because it was plus or minus. So it still ends up the same. If you pick a larger square number, you end up with less work. So that's always a goal for you. If I have a bigger square number in there, I should try to find it. If I don't find it, I can still do it. It just means more work on my part. All right, let's talk this one.
Subtract 25.
Let's subtract 25, and we get 9x squared is equal to negative 25.
Divide by 9.
Going to divide by 9, and we get x squared is equal to negative 25 divided by 9.
Square root.
Okay, take the square root of both sides. X is equal to plus or minus the square root of negative 25 over 9.
Then what I did, I moved it to x is equal to plus or minus square root of negative 25 over square root of 9.
Okay. One of the things that might actually, you could definitely do it that way. One of the things that might make it easier for you is like this. The square root of negative 1 times the square root of 25 over 9. You see what I mean? It'll work your way too, but let's just pull out that negative right there, that negative right away, because now it makes what we have to do to the fraction a little bit easier.
So you could just make that square root of negative 1 I.
Okay.
And you could square root that, then it would be 5 over 3.
Okay, so we get the square root of 25 over the square root of 9, and as he said, that is plus or minus I. The top becomes 5, the denominator becomes 3, and we get x is equal to plus or minus 5/3 I. Will we have fractions? Yes, they're going to happen. That wasn't so bad to deal with. It was more just like, wait, what do I do? How do I deal with that negative underneath the fraction there? Okay, so let's do just a couple more. Let's do A, B, C, and D, and then we'll call it stops. We'll call it quits there, because that'll be way more than we need to do. Okay. So we've got these things called complex numbers now. So check it out. We've got 3x, which we have always dealt with in the past. We have dealt with 3x. It's not a weird number. It's just something that, like, we have dealt with 3x in the past. But then we've got this negative 5i, which tells me that this part right here is an imaginary number because it has an I on there. So we're combining real numbers and imaginary numbers. It's two parts. What we call this is a complex number. It's complex. It's got real parts and imaginary parts. Notice that on the right-hand side, we've got a real number. The number 6 is a real number. And then we've got this thing, negative 10y times I. I know that must be an imaginary number because we're multiplying times I. And as soon as we do that, as soon as we do that, it's an imaginary number. So how in the world could I possibly solve this? Well, when we solve these, when we have complex numbers and we want to set them in an equation, we're going to set the real parts equal to the real parts and solve those. So notice the real parts are in red. We're going to set them equal to each other. Real equal to real. So here's what I'm going to do. I'm just going to make a note. Real equal to real and imaginary equal to imaginary. And when we do that, it's going to give us both parts of this. Like, we're going to be able to solve this here. So let's try that. Notice that we've got an x and a y. It's very difficult. There's i's in there as well. So what do? Real is equal to real. Imaginary equals imaginary. And the way that you identify the imaginary, again, is because they're the ones with the i's. That's how you recognize them. Yes, sir?
Did you maybe start off by dividing by 3?
Well, not everything up there is divisible by 3.
I know you thought everything else was kind of like, except the reaction of 6 that they were excluded. But
So we're actually going to be able to do that part. So here's the real part right there. We're going to be able to do that with the real part.
oh, okay, that's right.
Notice the real part there? It was 3x, and then on the other side was equals 6. So real is equal to real, And then I'm going to set up over here imaginary equal to imaginary. Negative 5I is equal to negative 10y times I. That's the imaginary part. Real is equal to real, imaginary equal to imaginary. Well, let's deal with that real equals to real. We've done this a million times. How do I do that? Let's divide both sides by 3, and I get x is equal to what? 2. The good news is it's not very different to work with these as well. In this case, it is y. I is not a variable. We're not trying to solve for I. We know what I is. But there's something that we can get rid of on both sides. Notice that there is an I on both sides. Check it out. What if I divided both sides by I? I's are gone. I's are gone. I poked out its eyes. So we get negative 5 is equal to negative 10y. Well, that just became a lot easier, right? Because once we separated the imaginary part out, we had imaginary equal to imaginary, which we were able to get rid of the imaginary part. So we end up with negative 5 is equal to, remember this is like a negative 1 being multiplied there, is equal to negative 10y. What do I do next? Divide by negative 10. Divide by negative 10. What is y equal to? 1/2. In which case y is equal to 1/2 and x is equal to 2. Remember, we're trying to find both variables, x and y. X is 2, y is 1/2. Real equal to real, imaginary equal to imaginary. And it's very easy to identify the imaginary because they're the ones with the eyes on them. We'll do B, C, and D, and then we'll call it a day. Okay, let's start by identifying what the real, I'm going to just write this a bunch of times until we get sick of seeing it. Real is equal to real, and I'm going to abbreviate this, imaginary equal to imaginary. So let's identify the real parts of what we have up top. What numbers are real numbers up there? 2x is real, and what else? And negative 8 is real. Notice that they didn't have i's attached to them. So let's just do that over here. 2x is equal to negative 8. Let's keep going. What do I do there to solve for x? Divide by 2. Divide by 2. What is x equal to? Negative 4. There is our real portion right there. Our real numbers are dealt with all right there. X is equal to 4. We still need to figure out what y is equal to. Let's identify the imaginary numbers. What are the imaginary numbers? So over here, we get negative 6i is equal to 20y times I. Now you're going to see this pattern happen a ton. What did I do to deal with this situation here? What was the first thing I did?
Divide by I.
Let's divide by I and get rid of it. Divide by I, poke out its eyes, and we get negative 6 is equal to 20y. From there, divide by 20, divide by 20, and y is equal to negative 6 over 20. Am I okay with that answer? Okay, divide top and bottom by 2, and we get negative 3/10. Y is equal to negative 3/10, and x is equal to negative 4. There are the two x and y using the real and imaginary portions. Real is equal to real, imaginary equal to imaginary. Two more. This gets a little more crazy because we have a square root in there, but that shouldn't stop us. All right. Again, I'm being obnoxious. Real equal to real, imaginary equal to imaginary. All right, talk to me. What are my real numbers up there? negative 8, and 5x. So what will I do with those things? Negative 8 is equal to 5x. And then? Divide by 5. Divide by 5. Let's identify the imaginary numbers up there. So we get 6y times I is equal to negative I divided by 6. What should I divide by? I, to get rid of the i's. Now notice over here, those go away. What would happen to the i's on the right? Well, they could if I would do this. Like, let's look at the top here. We've got, what if I had negative 1 times I times the square root of 6 over I? Then it's okay, right? Right. We would end up with negative square root of 6. So we get 6y is equal to negative square root of 6. Where do I go from there? I don't need to square it.
Could you divide by 6?
I would divide by 6. And we get y is equal to negative square root of 6 over 6. Why don't I cancel that square root of 6 and 6 out? Why don't I cancel those out? Yeah, you can't cancel a 6 and a square root of 6 together. They're not the same things. One is what I call an inside number, and one's an outside number. There is no square root in the denominator, so this is okay. I don't need to do anything to that. We'll do one more. That's my y right there. There's my imaginary part. Need to zoom out. And the last one we've got today is D. So, there's a little more going on this one, but it doesn't change what we're going to do. We're still going to do real is equal to real, and imaginary is equal to imaginary. So even though this feels a little different, we're going to go through the same process and see what happens. What are my real numbers up there? All those things that don't have i's on them, they're all real numbers. So when I set them equal to each other, what do you think I'm going to write? Good. These two are on the same side. Those two are on the same side. They're going to stay on the same side. 9x minus 5 is equal to positive 4. Where do I go from there? Add 5, and we get 9x is equal to 9. Divide by 9, and x is equal to 1. There's my real portion right there, dealt with. Real is equal to real, and imaginary is equal to imaginary. Let's deal with the imaginary. What are the imaginary numbers up there? Okay. So we get y times I is equal to negative 12i. Divide by I and poke out its eyes. And we get y is equal to negative 12. What am I going to do next? We divided by I right here. We just did that. What am I doing next? That's it. Nothing else. That's it. Because we already know what y equals. It's equal to negative 12. That's more than you need to get through today's lesson. It's actually probably enough to get through tomorrow's lesson too, but we're breaking it up into two parts. There's no reason to rush it all. That's enough for today.